Hello everyone, I'm Tarun Prajit from CSEI, graduating in Sri Venkateswara College of Engineering, and I'm here to give a presentation about multithreaded algorithms. In this presentation, we will dive into the fascinating world of multithreaded algorithm and learn about the benefits and challenges involved in creating them. Threading. Have you ever wondered how big programs can run so smoothly? The answer is threading. Threading is when program uses multiple threads to break up its work and do all of it at a time. It's like having hands working on a project instead of just one. What is a thread? Thread is like a small helper program that works alongside the main program. Threads can run in parallel, which means they can all work at the same time. This is especially useful for programs that have to do a lot of things at once, like downloading files or processing images. Types of thread. There are different types of thread, each with its own strength and weakness. User threads are like lightweight helper that can be created quickly, while kernel threads are like heavy duty helpers that can handle more complex tasks. Kernel thread helps the program to run more faster and efficiently. Threading is a way of splitting a bigger program into small parts, independent parts, and each running in its own thread. This can make the program run faster and more efficiently. There are different types of threading. By choosing the correct threading to your program, you can optimize its performance and stability. There are two types of threading, process-based threading and thread-based threading. Process-based threading is when a program creates multiple processes, each with its own memory space, file handles, and other resources. This approach can be more secure and stable since each process is isolated from the others. However, it can also be slower and require more overhead. Thread-based threading is when a program creates multiple threads and all of it is running in the same memory space and sharing the same resources. The approach can be faster and more efficient since this is less overhead and communication-based threads is easier. And in this slide, we will discuss about the importance of multithreading. In today's world of big data and complex applications, multithreading is essential for achieving optimal performance by allowing multiple threads to execute concurrently. Can take advantage of modern hardware and minimize execution times. Whether you are processing large data sets, running complex simulations, or building high performance application, multithreading is a powerful tool that can help you achieve those goals. There are many examples of multi-threading, which is in practice. One of it's like manufacturing, and the other one is real-time streaming, financial data processing, and many more. In manufacturing, multi-threading can be used to optimize assembly line processes, such as controlling robotic arms and monitoring quality control. In real-time streaming, applications that require real-time streaming, such as video conferencing and live broadcasting, using multiple threading to ensure smooth playback and minimize latency. Financial data processing. Financial firms use multithreading to quickly process and analyze large amount of data, such as stock and historical transactions, etc. And these are the common examples of multithreading which is in practice. There are many more examples which is in practice, which we will be discussing later. And but these are the most common multithreading which is in practice. In this slide, we will be discussing about the benefits of multithreading, which is increased efficiency, time saving, and fostering innovation. Multithreading can enable concurrent execution of multithreads, which can lead to fast execution and improved performance. And when it comes to time saving, by allowing multiple threads to work concurrently, multithread can save a lot of time and reduce execution time on long running programs. Fostering innovation. With multiple threads, developers can create more complex applications that can execute tasks simultaneously. In this slide, we will be discussing about challenges and limitations of multithreading, which are race condition, deadlocks, and increased overhead. When it comes to race conditions, when two or more threads access a shared resource simultaneously, it may result in unpredictable outcome. When it comes to deadlocks, deadlocks may occur when two or more threads are waiting for one another to release resource that they need to proceed. And when it comes to increased overhead, the use of multiple threads can require additional overhead in the form of synchronization, which can slow down program execution. These are the challenges and limitations of multithreading. Common multithreading algorithms are fork join model, map reduce, and thread pool. In fork join model, the algorithm involves dividing a task into smaller subtasks that can be executed concurrently, then joining the result together at the end. In MapReduce is a distributed computing model that involves breaking up a large dataset into smaller pieces, mapping each piece into a set of intermediate values, and then reducing the intermediate values to produce a final result. When it comes to thread pool is a collection of threads that can created ahead of the time and kept in pool for reuse. When a task needs to be executed, a thread is taken from the pool and assigned to the task. These are the three common multithreading algorithms which are being in practice. In this slide, we'll be discussing about the common examples of multithreading algorithms. Those are web crawlers, image processing, and game engines. Web crawlers. Web crawlers use multithreading to multithread simultaneously, scan multiple web pages for information. This process reduces the time to collect the data. And when it comes to image processing, multiple threading can also be used for image processing tasks, such as enhancing image quality and filtering. Game engines. Most modern gaming engines use multithreading to improve performance and increase visual complexity in games. These are the common examples of multithreading algorithm. And the overall summary is multithreading can lead to increased efficiency, reduced execution time, and greater innovation in programming. Future directions. The use of multithreading will continue to grow as developers seek to create more complex and further rich applications that can execute more tasks simultaneously. I hope this presentation have helped you in learning something about multithreading, its benefits, challenges, and algorithms, and examples of multithreading algorithms. If you have learned something new about multithreading, I'm happy to hear about it. And thank you for listening the presentation about multithreading. Thank you.